Okay, let's look at 10.7 or imaginary numbers. So early in chapter 10, we talked about numbers that are not real. And so if we had the square root of negative 25, we said that's not real because you can't take the square root of a negative number, which is true. It's not a real number. It's an imaginary number. And so now today we're going to talk about what is an imaginary number. So if you say that the square root of negative 1, so that any negative square root, we're going to let it be equal to the letter I for an imaginary number. And if the square root of negative 1 is equal to I, then we know I squared is equal to just negative 1. Because when you square a square root, you get rid of that, you get rid of the root sign. So when you get up into college algebra, you'll look at I to the third, I to the fourth, and even up to like I to the 80th. But for this class, we're just going to look at I and I squared. So anytime we have a square root of a negative, it comes out as an I. And anytime we have an I squared, it turns into a negative 1. So let me show you how we're going to use that. So at the beginning of the this test, we would have said that the square root of negative 25 is not real. That's true. It's not real. But now in test 4, we're going to say that the square root of 25 is 5, and that negative comes out as an I. So now we can take the square root, it just comes out as an I. This next one, this negative is out front, so that would just come down, and the square root of negative 25 is 5I. The square root of negative 7, we can't work with it if it's not real, so we've got to change it into an imaginary number. We don't know the square root of 7, so that's going to stay 7, but this negative is going to come out with as an I. So that's going to become I square root of 7. Because if they're written like this, we can't multiply them if they're not real. But if we change these to imaginary and make this an I square root of 3, and this an I square root of 19, then we can multiply them. So you multiply, variable times variable, radical times radical. So I times I is I, oops, I'm in the wrong place, I squared. And then 3 times 19 is the square root of, is that 57? Yeah. But now we know that I squared is equal to negative 1. So anytime you get an I squared, you change that back to a negative 1, or you can just think of that becomes a negative square root of 57, because you don't have to write that 1 if you don't want to. So really 2 imaginary numbers do you see end up being a negative. So let's look at this different. This one's imaginary and this one's not. So this is going to become I square root of 10. This is just going to stay the square root of 2. We don't have anything to multiply the I by, so it just becomes an I square root of 10 times 2 is 20. I should have said right here, you need to try to simplify this if you can, but there's nothing that will go into 57, so that one's simplified. But 20 would break up to be the square root of 4 times the square root of 5, and the square root of 4 is a regular 2. It's going to multiply by that I didn't leave myself enough room here, and become 2I square root 5. So if you can simplify the fraction, you need to simplify it. Okay, then let's look at division. So again, we can't do anything until we've changed them to imaginary numbers. So this becomes an I square root 50 divided by square root 2. There's nothing to divide the I with, so it's going to stay there. But the square root of 50 divided by the square root of 2 is the square root of 25. And then the square root of 25 is 5, so that becomes a 5I. If you wrote I5, that's not really wrong, except for that normally we always write the letter after the number. So the number first and then the letter. So let's look at adding and subtracting them. So just like we do with x's, you're going to combine like terms. So when I look here, I can add my 7 and my negative 11, and this is a plus here. So 7 plus negative 11 is a negative 4. And then we can combine our i's. A 15i plus a 14i is a 29i. Remember, when you add things, that exponent doesn't change. It's just like 2x plus 3x is 5x. When you add them, it doesn't change. And that's an imaginary number, is considered anything with the I there. This one's the same thing, but we just got to be careful of our signs because we're saying -2 minus 4 is a -6, not an I there. -2 minus 4 is -6. And then a positive 6i minus a positive 2i would be a plus 4i. Just add your numbers and then add your coefficients and the letter stays the same. Your exponents only change when you're multiplying. So let's look at these. So we're going to multiply number times number. 5 times 25 is 125. And then I times I is I squared. Because remember, when you multiply exponents, you really add them. But now we know from back up here that anytime you have an I squared, it turns back into a -1. So this becomes a -125. This one we're going to distribute the 3i times both things inside. So 3i times 4 is 12i. And then we have a plus. 3i times 9i, you're going to say 3 times 9 is 27. I times I is I squared. But remember, an I squared is actually equal to -1. So I always just think when you have an I squared, what it does is it cancels and changes the sign in front of it to a negative. So what you really end up with is a 12i minus 27. So the I squared just changes the sign of the number in front of it. Okay, this next one, we have a binomial times a binomial. So we're going to just FOIL it out or multiply all the combinations. So we really did this back in 0300, but we're going to multiply this 7 times both the things over here. So 7 times 3 is 21. 7 times I is a plus 7i. Then we're going to multiply the second one times both of them. So -2i times 3 is a -6i. -2i, that's like a 1, times 1i is a -2, I squared. Now, two things are going to happen here. We can combine our middle terms, but also our I squared is going to cancel out and change that sign to a positive. It was a -2, now it's going to become a +2. So we can say 21 plus 2 is 23, and then plus 7i minus 6i is just a 1i. So just treat your i's just like they're x's. I times I is I squared. The only difference is now when you have an I squared, you have to change it back to a -1. So these last two, remember an I is really the square root of a -1. So all of the rules for square roots apply. So when you're dividing, you have to do kind of like we did in the last chapter and rationalize the denominator. So if this is a 1 plus I, we're going to do the opposite, which is a 1 minus I over a 1 minus I. So really just like the ones we did, I think that was 10.5. It's just now you have i's instead of the square root. So on this top one, we're going to distribute. So this is going to become a 2 minus 2i. I just multiplied them both by 2. But on the bottom, you're going to have to FOIL this out and say 1 times 1 is 1. 1 times -I is -1i. Inside is a plus 1i. And then I times -I is -I squared. So you got to be careful how these middle will cancel out. This is like a -1 here. So this I squared is going to change that to a +1. So remember, the I squared just changes the sign in front of it. So for the bottom here, all I have left is a 1 plus 1 is 2. So because we rationalize the denominator, you should always get rid of the i's on the bottom, and that's what doing the opposite here does, cancels out all those i's. And then on the top, I have a 2 minus 2i. And then just like we did in 10.5, remember the triangle? If everything in the triangle can be divided by the same number, then you can reduce this. And so since 2 will go into all those, it just equals 1 minus 1i. You can put over 1 if you want, but the book is probably going to leave the answer like that. So rationalizing the denominator. Let's do one more that's a little bit harder. Remember, it's the denominator you care about. So I'm going to do the opposite of this and make that a 5 minus 2i, and then do the same thing to the top, 5 minus 2i. But now do you see we have to FOIL the top and we have to FOIL the bottom. So we got a lot of multiplying to do here. So we're going to do the 8 times both things over here. So 8 times 5 is 40. 8 times negative 2i is a negative 16i. And then we do 9i times 5 is a plus 45i. And 9i times a negative 2i is a negative 18i squared. And let's do the bottom. 5 times 5 is 25. 5 times negative 2i is a negative 10i. 2 times 5i is a positive 10i. And then positive 2i times negative 2i is a negative 4i squared. So let's look on the top here. So first on the top, this I squared is going to change that to a positive there. And then I can combine these like terms. So I can say 40 plus 18 is 58. And then negative 16 and 45 is 29. Okay. And then on the bottom, same thing, this I squared is going to cancel out and change that to a positive 4. And then these middle terms are going to cancel out. So on the bottom, I have 25 plus 4 is 29. Then again, I'm looking at my triangle, and since 29 will go into all those, we can divide them all by 29, which is going to leave me a 2 plus I. Because when you divide over 1, but again, you don't have to write the 1 anywhere. And that's your answer. So you're now ready to try the 10.7 practice problem.